Hello, today we are talking about variables. And this is a divergence from the last lecture where we said Python does math and everything's great. Everything feels right except for the floor divide and modulus, which are strange, but everything else is okay. This is different. And we can see that we have result is equal to 42 plus 42. And that still feels like math. This feels like an equation. If we were to calculate this ourselves, we would say 42 plus 42 is 84, so result is equal to 84. Yep, that's fine. And that is what would happen in Python too. So if I do exactly that, I'm going to say a result is equal to 42 plus 2, just to change it up. It says nothing back. That's because there's no output. It stored the output of the math into result. Neat. But here's where we diverge from math. Result is equal to result plus 10. And math people in the audience right now are saying, this is impossible. This is not math. And that's correct. Computer languages do things differently. What we're going to be seeing is that we have this right-hand side, and the right-hand side gets computed, computer science, and stored in the left-hand side. So what we have here is result. We know that result is 44. Okay, so it's going to say that we're going to say that it's looking up what is stored in results. Result is 44, so it's going to be 44, what we're storing in this variable. So it's variable, what could be in there? It could be any number. This is expecting a number, and it could be a floating point number, or it could be an integer number. We are assuming that result has a number inside of it. And this is exactly like x, right? Those are variables too. It can hold any number. It's going to look up that number, add 10 to it, and then store it back into result. And there's still no output. Well, that's because it's stored. So what's 44 plus 10? 54. Neat. I think I just jumped way ahead in my slides. Oh yeah, okay. Calculate the right, assign to left. You'll hear me say that a lot. Calculate the right, assign to left. Calculate the right, assign to left. That is how it works. Variables, and I alluded to this already, are loosely typed. This is a feature of lots of scripting languages. Python is a scripting language, not a compiled language. And it is loosely typed. So results, I'm going to say maybe A for a case of example here. A variable is equal to 10. Okay, so a variable is currently an integer number. And then I can say 10.1. Okay, a variable is now a floating point number. I could also say a variable is equal to words. We'll get to strings later. Now a variable is equal to words. Result is equal to, hey. Now, what happens if I say result plus 10? This is where that dark magic part comes in. Sometimes it's going to yell at us. Sometimes it won't. In this case, it will. Because I'm trying to add a word and not int to a string. So it doesn't like that. And that's fine. And that is one of the drawbacks of a loosely typed language. That our variables, we don't know what's in there. And this isn't usually a problem provided that we are using variables well. This would only happen if I reused a variable name. So variables are, as you've seen, I've been just jumped in because you've seen variables. X is equal to 10. You've seen variables. Well, we can name them anything, provided it's a bunch of letters. There are some limitations. They can't just be willy-nilly. You can't have, plus in there because it's going to try to add something. It has to be basically Roman letters, uppercase, lowercase, underscores work. But when we're being loosely typed, we can make the mistake of reusing a variable name. So result is equal to hey versus result being a number. So we need to avoid that. And somebody probably most of you, maybe all of you, sometimes including myself, will make this mistake because we're actually really bad at naming variables. I had an easier time naming my children than I have naming variables. And you think I'm joking. You're going to find out I'm not. So try to do our best to not reuse variables names for different things in the same script. And that Python code files are called scripts. So we don't have to declare them. If you've used C, C++, Java, C#, most other languages, you'll have to do something called a declare a variable. We don't have to. Python doesn't have. That's not a feature we have. We just make up names as we go, and we just assign values into them, which is pretty cool. The type can be changed if we're not careful. To float, int, and more, you saw string. And I already talked about this at length last class. Variables and code are for humans. They happen to be able to run, but the computer cares a lot less about what your code looks like. What we want as an output of this class, as an expectation of this class, is that you'll be able to write readable code, and readable to a human, not to just a computer. It does have to be able to be readable by the computer, but that matters less than having a human come and read your code. Because if a human can read it and make sense of it, a computer can easily make sense of it. So a really tempting thing here is height. A equals W times H. That feels really good, doesn't it? This is actual math. All the math people in the crowd are saying, yes, I understand this. But what we want in this class is even clearer names. Area equals width times height. This will always make sense. I can write this, leave, and come back a year from now, and it'll say area equals width times height. And I'll say, heck yes, it does. But if I say, see, A equals W times H, well, this could mean anything. If I know the context of 2D shapes, oh yeah, no, this makes sense. But without that context, it's just A is equal to W times H. Maybe Alex is equal to Walter times Henry. I don't know what it means. It doesn't make sense. So we want good variable names that are sometimes longer. But that's okay. What we want to do is be able to debug our code later. And because sometimes bugs slip by, or sometimes somebody else is looking at your code and has to make sense of it. So use longer names. These are some options about how we can name variables. Lowercase separated by underscores. Underscores are a valid character you can have inside of your variable names. Things like plus signs are not, because that will be interpreted as math, not as a character. Lower camel case works too. So that is, first letter is lowercase, and then all the following words have an uppercase letter to follow it through. I really like that. That's how Java likes it, and Java was the first programming language that I knew well, so I tend to go to that. If you like that lowercase separated by underscore style, you're welcome to use it. Using them, well, now we can store values. One of the things that we want as programmers is to have repeatable code and have things work in a repeatable manner. So I'm going to jump over to Spider here. I'm going to click on the new file, which is the button on the top left, and it's going to be named untitled. And I'll save that into my Scratch folder probably, or maybe a home folder. You should save these in a sensible place. I'm not sharing, I guess I could share my whole desktop. I think it's this button. Yeah. So file, save as, to save somewhere else other than just your home folder. And then put it somewhere sensible. So I'm going to put it into examples here. I'm going to make a new folder for y'all. And I'm going to make a week 1. And then I'm going to add well, I'll just put it right there. That's okay. And which I name it? I should name this something meaningful too. I'm going to name this variables. There we go. And I saved the wrong one. That's okay. I don't really care. I'll get rid of this. Good. So what we want is to be able to run code again and again and again. And looking at my example here of area, height is equal to 10, width is equal to 30. So then area is equal to height times width. Save. Oh, all right, so now I have a repeatable program saved on my machine. Cool. So I can run this, life's good, and this is where my output will go. It doesn't print anything right now. Well, if I click on this Variable Explorer button, it'll actually show me right here. Go back to my full screen. So these are all the active variables in our program, and we can inspect them after our program's done. We're going to talk about printing and how to do pretty printing next class, but this for now works for us. Or even down here, I can type area and it'll give me what is stored in that variable. And you can see that these variables are just bins. They're bins that hold numbers or words or something, and they are just something we can look up. And you're probably sitting there thinking, well, Rob, why don't you just do this? 10 times 30. Well, future versions of you, do you think this is going to make sense later? Well, yeah, okay, well, we have 10 something units by 30 something units, and it's stored in area. Okay, that's fine. But I don't want to write a program twice. I don't want to have to write a program every time I want to calculate area. And if I want to calculate volume, I don't want to have to type the same numbers twice. Times depth. Depth is equal to 5. Well, now if I wanted to change this 10, I'd have to change it here and here. And if you've ever copied and pasted anything in your life, you know that this goes poorly. You'll propagate mistakes, and the mistake will go everywhere, or you'll forget to update one thing. I'm terrible with dates about this, where like I have dates in 3 places and I forget about the 4th. And that's because I've trained myself to not care. I want to just have one variable that is true. Oops, that's not what I wanted. That'd actually work. Oh, neat. Height, width. Or, that's a comment. If you start things with a hash, the octathorpe, the pound sign, it's a comment. Times. Now we have some really repeatable stuff. 2 options to calculate volume. So here you can see that I have all my what these are called control variables. So if I ever wanted to calculate the area and volume of some other box-shaped object, I can just change these. And then these variables will get reused through my whole program, so I can calculate the area based off my control variables. And then I have 2 different ways I can calculate volume. I can either reuse height and width, or I can take this area that I already calculated and drop that into here and just multiply that by depth. And then every time I hit play, it'll happily calculate all this stuff for me, and then I can see my volume over here is 1,500. This is nice. We do want to have repeatable science, and this is step 1 in that, which is separate your inputs from the calculations. That's what we want. And then if we ever wanted to do this experiment again, if we ever wanted to do our engineering math again and don't want to type everything into our TI 83, 84, I don't know what they're called. I use Python. I can just say, okay, change these variables. Let's see what the result is. If you ever used a spreadsheet in a really meaningful way, this is kind of a similar concept. The equation need not change. Whew. Okay. Global variables. Some things don't change. Pi, for instance, is a well-known number. You probably know it to more digits than I do. 3.14159. That's from my memory. It might not even be right. The speed of light also doesn't change. It is a fact. So we want to keep these in all uppercase separated by underscores. That tells us that this is a constant and that they shouldn't change. Thanks, Python. Thanks for not enforcing that. But it'll be able to tell us, the programmers, that we shouldn't change them, though we could. We shouldn't. Comments, I already dropped this earlier, are these lines that are preceded by a pound sign or octothorpe or hash, whatever you want to call it. And will give us more context for our programs, because sometimes programs don't make sense without them. If you have very good variable names, it should be telling a story, but these give more depth. Without this comment, what does 299,792, like some people might be able to recognize this as the speed of light in meters per second without the comment. I am not one of those people. And even being able to say what unit something are, those don't get captured in these numbers. This is just like a scalar number. It's like, here's a number, ho ho. This gives us more context. So this is in meters per second. Okay, that means that I'm going to do all my calculations using meters per second, or I need to convert it. And that's fine. So this is, I keep on saying the code is just for humans. These comments are exclusively for humans. Python will just ignore them completely. It's like they don't exist. So you can add these as much as you want, and it will not slow down your program. It will just be good for you, the programmer, later to actually be able to read your programs. So in summary, variables hold information, and comments will help us know what this information means. And good comments and good variables will actually make our code readable. All right. Have a good day.